All right, so up next is going to be AgriFeed Pro. And if I could just remind you, before you share your screen, please come on screen, introduce yourself and your country, and then you can start your presentation after that. You'll have 3
Greetings to
minutes to
everybody.
start. You'll have 3 minutes to start, and I'll give you a 30-second warning before your 3 minutes is up. And whoever would like to introduce themselves first, go right ahead.
Sure. Greetings everybody. I am Bhuvan. We are from AgriFeed Pro. I hope you can see me and I'm audible. Even my teammates are here. We are from Mysore, India. Right?
Very
So
good.
we'll start presenting. I'll just share
Wait,
my screen.
can your teammates please introduce themselves as well?
Yeah. Nandan and
And then,
Aryan, if you can go ahead.
I'm Nandan. I'm from Ex Public School, Mysore, India.
Yes,
oh,
I'm
say that
Aryan
again.
Kini.
Say that again. I'm sorry. Wait. So what happens is when you speak, the screen delays a little bit. So say something, and then when your picture's on there, then say who you are, please. So you're already
Nandan Hegde.
okay. What's your name?
Nandan Hegde.
Perfect. Thank you.
I'm from Ex Public School.
And your third teammate.
Yeah, I'm Aryan Kini. I'm also from Exeter Public Schools, India.
Okay, thank you. And then you may begin.
All right, we'll share our screen.
Okay,
I hope it's visible for everyone.
it's coming.
Yeah.
There you go. It's perfect. Thank you.
Sure, then we'll be starting off now. Greetings everybody. We are AgriFeed Pro. We have a vision to create we have to create a sustainable and thriving agricultural ecosystem using technology, scientific practices, and traditional methods, using technology and innovation. So we did our market research and were able to identify the following problems. Problem number one: cattle and other animals which are raised by small scale farmers often do not get nutrient rich fodder during the agricultural off season. And secondly, if you read news articles, especially here in India, you'll find out that in regions of Uttar Pradesh, Haryana, and Delhi, there is huge CO2 emissions due to burning of stubble. And this is not a sustainable practice as it's causing a lot of respiratory issues for the people living there as well. And small scale farmers of our country are still in the low income group, despite making the best of the resources. So we saw these problems and we ideated some solutions. We were able to ideate three solutions. Our first solution was an automated, low cost, sustainable machine that can make nutrient rich fodder for farmers to store during the off season. Secondly, we developed a method by which we can use stubbles to create green fodder so that the stubble is not burnt, in turn, not causing CO2 emissions. And thirdly, we developed a methodology by which the small scale farmer can earn more income supplementing his farming activities. So, keeping all this in mind, we designed our solution, the AgriFeed Pro. AgriFeed Pro is an automatic silage making machine that is designed to revolutionize the way farmers preserve and protect the nutrient rich green fodder. Currently, our system is able to produce 2 kg silage packs and it has different modes as per the needs of the cattle. So, as of now, it can be used to feed pregnant cows, calf, bull, and milking cows. And our system has a solar panel with a solar charge control, ensuring efficiency and eco friendly operation.
Building on our initial 2D blueprints, we developed the 3D design you can see here. These different views allowed us to visualize the product as it would appear in real life. Before moving on to building the machine itself, verifying the design in a virtual environment helps us, it will ensure as intended and it will reduce the risk of material wastage. And while ideating our product, we went through a lot of ideas. And with the help of 3D designing, we could bring it to life. Over to Nandan Hegde.
This eco-friendly system is powered by a 40-watt solar panel and a 12-volt battery, ensuring that even in the absence of sunlight, energy is efficiently stored and utilized. The process begins when the user selects the cattle type, the milking cow, calf, goat, pregnant cow, or a bull using the LCD display. Once selected, the high-speed 7000 RPM motor starts. This is the chopper unit, cutting the fodder into fine pieces. These pieces then move on into the mixer unit. At this stage, the system uses a humidity sensor to monitor moisture level. If the fodder is too dry, a submersible water pump adds water, ensuring the optimal environment for fermentation.
Pardon me.
Meanwhile,
30
jaggery
seconds.
and material mixtures are automatically dispensed from specialized canisters based on the type of cattle selected, powered by 10 RPM motors, ensuring the feed is nutritionally balanced. Next, the mixer is driven by Johnson motors at 30 RPM, blending all the components thoroughly. Once mixed, a tractor controlled by 3D printed rack and gear mechanism opens to release the silage into biodegradable bags. This is then compressed using the same mechanism to prevent mold and bacterial growth. These airtight bags ensure freshness for about 8 to 9 months, providing livestock with year-round nutrition even during the off-season. The entire process is powered by an Arduino Uno, ensuring smart, real-time monitoring and control.
Thank you for joining us for this presentation. We're open to question and answers.
Okay, Antonella, would you like to start?
Yeah, so we're done to address to make an effort to to address the future of sustainability. So you mentioned on one of your slides about free solution. So I was I was interested about solution number 3. So what are the farming activities that will help to earn more money, more income?
Okay. So what we're able to do is using this machine, right? You're using your agriculture stubble to create silage. And this silage can be sold. So we have a business model. If you're interested, I will show it to you. So we call it the synergy silage pack. So basically when each farmer buys our machine, he's able to make silage packs, which we buy back from him and sell it in the market. So excluding his fee, money from the harvest, he's also getting additional income making silage from our machine. So this is the new methodology of making money for farmers that we are talking about using our solution.
Okay, great. Yeah, well explained. Yeah, thank you. I'm going to pass to Nancy.
All right. Thank you. I think this is fantastic in terms of how to remain sustainable and also to reduce CO2, which is very important. Now, I like to know, following on Antonella's question, since the farmers have to buy the machine, how much are you selling the machine for?
I'm glad you asked. We have a slide of the finances as well. I'll just pull it up for you, if you're able to give me a minute. So we did some costing parameters. So currently the prototype cost 23,516 Indian rupees to build. We think a minimum viable product would be somewhere around 27,000 and manufacturing at 29,000. So if you're able to project it in the market for 38,700 rupees, we think it's a good buy for the farmer as well. And we also have something on the side, around 4,800 rupees. So it's around $500.
So how many packs of silage would they need to sell to recover the cost from these machines?
So as you can see, each 2 kg silage pack, we would be buying back from them at around, 8 to 18 rupees. So I think in 1 year or 2 years, that's around 4 to 8 harvest seasons, they'll be able to make their money back in order to break even.
Right. And so in terms of the CO2 impact that you mentioned, what type of savings would we be looking at because they are churning the fodder into silage?
So currently what they're doing, once the harvest season is done, they take all the, grains and whatever's left in the field, they're burning it up. Reason being, it's a lot of work for them to cut it up and properly dispose it. So it's been a case where the air quality index of Delhi, that's the national capital, is very, very low. So we'll be able to offset this emissions using the machine, since you're giving that extra, stubble another form of usage, which is silage.
Okay. But no measurements of the CO2 savings was done with this prototype.
No, we haven't projected the CO2 savings yet. We are from the southern part of the country, so we just tested it with what we have. We will look into that. I think we should research about it, as you said. We will get back to you once we have the numbers.
Yeah, it would be good to look at it because you've identified the problems. You've also projected the process, which is the solutions you want to take. Now you've worked on the economical side for the farmers, but what's lacking would then be what type of savings would they provide for the environment by doing so in terms of CO2 as well. So I think that would be
Understood.
a very balance and measurement for you.
Got it. We will do that.
Okay. Julie, do we still have time for another question?
Yep, we have about 40 seconds.
Then I would rather just
No, you're
thank
okay,
you,
because we're going to actually, because we have a little more time in this session, I'm going to ask students next.
Okay.
So if you'd like to
All right.
ask a question,
okay,
go ahead.
Sure. Right. Now, for this particular project, with the MVP part of it, what would you change from the current prototype to the MVP?
So one thing we have to change is, I'll just pull up the machine. So currently we tested it with some tender fodder like barley and paddy, right? And the stubble of that is different from, say, for example, sugarcane, where the size of the fodder is different, size of the stubble is different, right?
Right.
So our chopper unit is not so efficient as of now to cut big stubble like sugarcane. So maybe we'll develop another chopper that's standalone, which the farmer can buy to add on to the machine, so that we're able to cover more stubble, so that more types of silage can be made. That is one improvement we are eyeing. And we
Okay.
also, as of now, in terms of the silage packing, we're able to compress the bag. We don't have a sealing technology as of now. I think adding that would make it beneficial for the machine too.
Okay. And your costing for your MVP includes the additional components that you just mentioned.
Yes, ma'am, that would be correct.
Okay. All right.
That's why
Thank
you
you
can see
very
a
much.
difference there.
Well done. All right.
If I just have a 10-second video of the machine working, if you would like to take a look at it.
Yes, please. Thank you.
Yeah, I'll just pull that up. It takes about 1.5 minutes to complete this. I've sped up the video. And we also have a 10-second 360-degree view clip for you to take a look at.
Thank you.